Good morning. It's really a pleasure and privilege to be here speaking to a community of experts such like yourselves. And thank you for sticking before lunch and enduring this last half an hour before the meal is served. Would like to thank the NANOG program committee for reviewing and accepting this presentation. My name is Hosein Badran. I'm senior technical advisor with the Internet Society based in Ottawa, Canada. Before I used to work for Cisco, I left as a distinguished architect. Being based in Ottawa, 2 days when I left was minus 27 degrees Celsius. So it's a very positive change to come here and see the sun with some warmth actually shining. The point of connecting indigenous communities in North America is something that really the Internet Society cares about a lot. And we'll review here some deployments that we have done over the last year and we are embarking on as we speak, as well as some key lessons learned from these engagements. We'll talk at the status of connectivity, particularly in the Canadian North. Last talks in NANOG Austin, our partner Matt Rantanen spoke in detail about connecting tribal lands in the US. So my talk will complement this point by looking more further into the Canadian North challenges, but giving examples from both Canada and the US. So define what community networks are, look at examples as I mentioned, and look at issues that relate to capacity building, challenges, opportunities, as well as key point of lessons learned. Before I start, maybe a few words about the Internet Society. Maybe some of you know it, but just as a refresher, we were founded back in 1992 by the founders of the Internet, or Internet pioneers. We are a global nonprofit organization dedicated to ensuring an open, accessible, resilient Internet for the use by everybody. The Internet Society is based on, we have a network of about 64,000 members, more than 130 chapters worldwide, and special interest groups. One on, for example, indigenous networks or community networks, as well as we have more than 100 organization members. We work a lot through our chapters, so it's really a bottom-up kind of approach, collaborate on broad topics from the technology policy issues, technologies in particular that keep the internet safe and secure and resilient. And we serve as the organization home for the IETF, the Internet Engineering Task Force. If you look at the connectivity status in the Canadian North, basically we have, particularly in the eastern part of the Canadian Northwest Territories, Nunavik Territory, we have the majority of the communities are satellite dependent. More than 42 communities have been counted by ISAD, the Ministry of Innovation, Science, Economic Development of Canada. In one of the last census, these 42 communities are completely satellite dependent. A very small number have access to other backhaul technologies, microwave or fiber. And satellite in these communities is quite expensive to say the least, and of course, unfortunately, quite unreliable. I'll give one example. One of the communities that we're going to talk about in more detail, Uluhokhtak, although in the Canadian North, although the nominal speed should be around 5 megabits per second for the whole community, what they see is typically an order of 1 megabit per second for the whole community. Another challenge is small number of providers, no competition really, and there's no appetite to invest in that part of Canada because the return on investment is small. Small population, remoteness, and difficult terrain make the appetite for operators to go there and invest quite lacking. And this is a map of the eastern part of the Canadian North. And we see here the communities are satellite reliant, and most of them, or all of them, have really bad connectivity in terms of broadband. So this is really something that impacts the communities in that part of Canada deeply in terms of economic development, educational development, delivering health services. All these are definitely negatively impacted by lack of adequate broadband services to these communities. The government has started some initiatives in trying to bring broadband connectivity to the north by committing to invest $2 billion next 5 years in terms of infrastructure, in terms of universal broadband fund, in terms of running a census by statistics standard to find out the details of what exactly are the communities suffering from in terms of broadband connectivity. Unfortunately, this is very good, but it takes time to deploy. Another project by Infrastructure Canada, Bank Infrastructure Canada, will link a fiber cable from Greenland to the Canadian North, from Greenland, which is far east, to the Canadian North here. This will take at least 5 years to deploy. And its cost, because it has not started yet, is increasing from 140 million. Now it's 200 projected, and if it doesn't start, it will even increase more before it even starts. So the situation is quite difficult. The approach here is to build a network, allow the community itself to build connectivity for its own use and its own benefits, and try to harness the benefit of having a broadband connection for, as I mentioned, educational services, health services, and economic prosperity. The foundation concept of community networks is it's a do-it-yourself kind of solution. The community members themselves rally along each other and build the network by themselves, learning the technology and getting the hardware and building the network from bottom up by themselves, in many cases by external support experts or from funding by external sources such as the ISOC or the Internet Society. This kind of approach is completely community dependent. The community has to rally behind this cause and make it one of its priorities, to build the network and see it up and running. Not only that, but keeping it up and running in the future and looking for models for sustainability of funding of this kind of project. It's a community effort to be led by the community, to be built by the community, operated by the community, but relying on larger sphere of supporters, technical, funding side, regulatory side, to help these communities flourish and grow and be sustainable. And community networks are really complementary to network provided for commercial use by operators or by others. They don't replace, they complement. In the words of one of the inhabitants of Uluhokhtak in the Canadian North, as you will see, she says community networks keep the community money within the community by operating our own network and create training and employment opportunities for residents. She has to pay more than $250 a month for simple connectivity, for simple voice connectivity, which is really something that is quite a burden on this type of communities. Moving on to examples, we have an example in Hawaii and an example in the Canadian North. If you think about Hawaii, you think really about Waikiki Beach, you think about the commercial strip, you think about the beautiful landscape, beautiful scenery. 45 minutes drive on the other side of the island lies this community. Pu'uhonua Waimanalo, the sanctuary of Waimanalo, is basically a community, what they call themselves Nation of Hawaii, based on about 30 or 40 homes on the side of the mountain, and they really lack fundamental technologies. They have voice connectivity over the 4G network, but in terms of broadband to the houses, this is completely lacking. In the words of one of the inhabitants, he has to run to the house of the chief and steal the USB LTE dongle, use it for his home, for doing his homework while the chief is away, and by 1 or 2 a.m. in the morning, before the chief returns back, he runs to his house and puts it where it's supposed to be. The other story is that it's a habit that the children, school-age children, have to be put in a van and go to Starbucks for 4 hours to do their homework. That's the only way they have access to the internet. This kind of community really became a pioneer in asking and rallying behind implementing community network projects on their land. The solution that we have opted for, along with our partners,
is basically an LTE unlicensed licensed spectrum kind of network at 5 gigahertz. And what was sufficient for this size of the network to deploy E2 node Bs, and in this location, E2 node Bs facing this direction and this direction, and then having CPEs, outdoor CPEs on a number of homes that have typically children at these homes. And then inside the house is connected to CPEs who have Wi-Fi routers to have larger coverage of signal coverage. This community has been quite lucky. And there was fiber termination just outside the fence of the village from the local operator. So the community really had to dig a trench from where the junction box is on their own land to where the node B termination will come. And they did it on a voluntary basis on their own land. They themselves did it got the equipment and did this kind of termination. And the cost has been lowered by the operator to about $400 per month for 2 gigabit per second capacity. This is the picture of the E node Bs and the CPEs on the houses. These are list of partners that were engaged in this approach, and you see here NANOG listed. Edward was kind enough to participate in this effort and show support, NANOG support, to make it successful. The second example is the Uluhokhtak in northern Canada. Uluhokhtak is here at 71 degrees north, horizontal north. And it's a very small, it's a community of 350 inhabitants that really is completely satellite dependent. 1 megabits per second is really what they see on a usual daily basis. We are planning to deploy an LTE solution in this network as well, based on the partnerships that we have with particular provider. How it came about through discussions in the Indigenous Connectivity Summit, which is a summit that the Internet Society implements on a yearly basis, bringing indigenous communities from across Canada and the US together, talk about the challenges and examples and things that we can do together, bringing in also government officials and academia and other experts. So they showed support in summer 2019, identified leaders who want to make this happen within the community, and we began the training for both Uluhokhtak and Hawaii in the summer of 2019 for 3 months. By December, we're ready to deploy the network in Hawaii. The Uluhokhtak network is still not in deployment phase, mostly because of logistics of shipping the gear to the Canadian North is really very weather dependent, and you have to basically wait for the spring to be able to ship any antenna or any termination points that far north. Another challenge with this kind of network is the cost. The cost of the satellite termination, and as we will see that we want this to be really from a geostationary satellite moving to low Earth orbit satellites, to LEOs that are coming at the end of 2020 or 21, and this makes the solution quite expensive. This is another obstacle for deploying networks in such a territory. We had significant training done, and this is very important for the community to grasp the skills, the technical skills as well as the soft skills in terms of business acumen, financial planning, project management, how to access funding, how to request funding, and of course the technical skills, how to build the network and operate the network. Final part of this training that is delivered either face-to-face or mostly in the preparatory phase online through about 16 online sessions done by community members that have run through this on their own communities. An important aspect is the local hands-on training. The hands-on training is really for the community. So you see here in these pictures, the ladies within the community were the ones that really at the forefront wanted to learn how to terminate an Ethernet cable, how to plug into the CPE, how the configuration of the node EB is done. And this picture shows the chief of the group in the community in Waimanalo teaching his grandson how to terminate the Ethernet cable. he asked him to stay out of school, stay at home with the community on Friday, so that he sees this firsthand and he can teach him how this is done. And this is the way to make this project successful. Community has to pitch in, has to learn themselves, operate, build and operate the network. Financial sustainability is a key point that needs to have this project up and running for a long time and in successful fashion. In terms of technology directions, this section will talk about 3 technology directions. One of them, as I mentioned, is the part of moving from geostationary satellites that are at the height of 35,000 or 36,000 kilometers to something that is much lower at 1,200, 1,500 kilometers from Earth, and then overcomes latency issue. The two-way latency of a geostationary satellite is the order of half a second. For low Earth orbit satellite or LEOs, it should be in the tens of milliseconds. So this is really improves a lot the latency, the performance, and the promise of much higher bandwidth availability than that for geostationary satellites. In this slide, we have two operators that are focusing on this space, OneWeb and Telesat, and they promote fiber kind of bandwidth. Hundreds of megabits per second. One of them talks about 1 or 2 gigabits per second that download/upload capacity that is the promise to be delivered within a specific time frame. Telesat talks about 600 satellites by 2022. OneWeb starts already a launch of 40 satellites a few days ago that was successful. The promise is 360 satellites by end of this year, moving to 2,000 satellites in the future. Again, the promise is fiber, virtual fiber kind of connectivity, capacity and resiliency, hopefully with this kind of competition, 4 operators are in that space, that prices will be more attractive for communities that are really suffering for lack of bandwidth in the northern Canada or on tribal lands. In terms of the backhaul as being one of the key challenges really to deploy a community network, particularly in remote indigenous communities, Internet Society has put together a fact sheet that looks into the different options, being wireless or being wireline options. On wireless, we have a microwave, we have satellite geostationary, we have low Earth orbit satellites, we have Wi-Fi, of course, or TV white spaces. All these are technologies that are being adopted for deployment of backhaul solutions. On the wireline side, typically it is fiber optic. If fiber optic is available, it's most cost-effective, future-proof kind of backhaul solution. But unfortunately, it's not available everywhere, and it's not really cost-effective in places like the Canadian North, where distances are huge, and you have to rely on some sort of wireless capability. This fact sheet is available online, and it can be accessed through the URL that is here. The technology that has been used in Waimanalo is an LTE architecture. And the choice was because of an existing partnership with the vendor that proposed to deploy the hardware for free, and also, which is very important, help with the support and training of community members and the online support after deployment. This is very key to make this project successful, and we're happy really that we have partnered with them. This kind of architecture, we have the end user equipment, which in our case, the outdoor CPE, the radio access network, of course. In our case, selected unlicensed spectrum at 5 gigahertz. And then you have the evolved packet core. In some cases, it's hardware-based. With this kind of solution, or this kind of vendor, it's software that lies in the cloud. It's a cloud-based solution. One element that is not shown on the slide is the local gateway. Local gateway has to be configured as part of the solution. Its function is to split the data plane from the control plane. Data plane remains within the local gateway. The control plane goes to the cloud, does all the control functions, and comes back again with any control information needed. So this is what has been deployed, and it's fair to say that it's an elaborate solution in terms of configuration effort that needs to happen to deploy the solution successfully. Of course, you have to register the end users. They register through the SIMs set in the CPEs. And if one of the SIMs is not registered the right way, connectivity does not happen. So there's a learning curve for community members to learn how this is done. And typically what we have seen within the community, it helps a lot if at least 1 or 2 people are network savvy, have some background of networking, and they can grasp the elements of this kind of effort or this kind of configuration work easier than the rest of the community, which can help with the other types of installation activities. The third component in the technology direction has to do with spectrum. And spectrum, as of course you know, is a really scarce resource. In the US, the FCC has embarked on making part of the spectrum available. It's the 2.5 gigahertz band, what's called education band spectrum. Usually was restricted to use for schools and libraries, for usage on tribal lands that are recognized indigenous tribes. It was allowed to use for other services, for internet connectivity or fixed wireless services, with restrictions. The restrictions are the rate of deployment has to satisfy specific metrics. 50% of the area within the tribal land has to be covered, or the population has to be covered within 2 years. Within 5 years, 80% of the population on the tribal land has to be covered. So these are significant metrics that the tribal councils, when they apply for this spectrum, has to really plan for and make sure they can deliver on this commitment. The window of application for the tribal communities have opened in the beginning of February 3rd. And for 6 months, the FCC is accepting applications from tribal communities. And this is very important for tribes in the US to apply for this spectrum. It's really a scarce resource, and the FCC has made it available after consultation with the tribes, with many entities, including at the ICS in Hawaii in last December, and made the window for 6 months to allow for this kind of input from tribal communities. What we see as challenges and barriers of opportunities from this work that we have done with our partners. Of course, in terms of challenges, the geography, where these communities lie, the remoteness of these communities, bringing not only hardware and connectivity, but also bringing experts there. To go to the Canadian North from Toronto or Ottawa costs you at least $8,000 for one person, and about 2 days each way. So there is a challenge to getting to the community. The cost of bringing the hardware and also of the operating costs moving on. As we've seen from the case of Uluhokhtak, we need at least $200,000 to maintain connectivity at the capacity that makes a difference. Licensing and permits, this is important. The case of Hawaii, if the digging of the fiber was not on their land, licensing and permits was really an issue, and that would have taken 6 months to a year. Access to funding and access to spectrum, as we mentioned, are key challenges that have to be overcome by the community. Although funding can be available from the government, in the case of the Canadian government, but the funding criteria makes a significant barrier. For example, to apply for funding from ISAD, you have to have 5 years of auditable budget from the community, which is not available for a startup kind of project, or you have operational experience for 5 years, or operational experience for 5 years, which is also something that is not available in such a community. The opportunities are really numerous. That community support, if it is there, it has really a guarantee to make the project successful. Funding is available from different sources, including civil society. Technology does not have to be complicated. There are solutions which can be deployed without too much knowledge, with help with experts around the community. Other technologies to use and so on will make backhaul solutions more available. And it has been done by communities across the globe. And there are a small network of experts, what we call special interest groups, that really share experience, share know-how, and share their knowledge of how to overcome challenges together. And this is a much needed support for uprising communities or new communities.
The lessons learned are basically in two categories, one on the community side and one on the technical side. On the community side, it's really absolutely necessary to find a local champion and for a community to rally behind the project. And also, you should take time in preparing the community members, capacity building, skill development before the start of the deployment. This is really key. They should not be just observers to the network to be deployed and operated. They have to do it themselves. So they have to learn, and in many cases learn the hard way, see the network not up and running, something is wrong, misconfiguration. They have to learn how to do it themselves with the support of the extended community. Technical hands-on training and deployment of community members is key, as well as we're verifying the details of the infrastructure and connectivity before the start of any deployment. As we have seen in the case of Hawaii, we didn't really know before a deep, in-depth site survey was done that the junction box was this distant away from the community. And we had to dig to bring the fiber inside. So this kind of information has to come by strong engagement with the community, multiple site surveys, relying on experts being there and identifying the challenges. And you have to take your time. Community building is a time and effort consuming activity, but this is the only way to success. What we would like to show now is really a video of the Waimanalo deployment that the Internet Society has done at the last day of deployment.
This already changed my life because I feel like I really can do it by myself. I'm crying because it really helps us. In this state, it is really hard to survive. It really is hard to survive. So us having internet here, we don't have to leave this place. We now can make money from home. We can do a business from home. I mean, it just means freedom to us.
So being independent, you have to do your own stuff. You have to run your own power. You have to run your own water. You have to build your own roads. And we've done that over here for the last 25 years. We've built our own houses. Now we've built our own community broadband network. Our internet service prior to this build was very spotty at best. We had cell service. There is one house that was getting internet off of this one pole here. But other than that, everybody else's internet was really terrible. They had a dish service, usually satellite internet, and in order for that to work, other people had to not be on the internet, so you could only do one thing at a time.
It's going to be independence. Where we live here at Pu'uhonua, Waimanalo, we strive for total independence from the fake state of Hawaii. We've been under illegal occupation of the military for the United States of America. This allows us to continue our stance of independence on the web.
Personally, for me, it makes me feel like I have allies all over the world. I have allies in different sectors that we can reach now because of our internet, and it'll make our job easier. It'll make our nation's job easier.
It's going to be amazing, especially when I start school, because then I can do my homework in a better, productive way. And then my kids' iPad will stop buffering and they will bother me while I try to study.
Kids oftentimes had to go down the road. They had to go to McDonald's. They had to go to Starbucks to finish uploading their projects. So and it was frustrating for a lot of the parents because they had to, they had to kind of rearrange their lives and just to keep their kids from falling behind.
We started to realize that the kids were all online. They were learning everything online in school. It made me realize that without this technology, without the involvement in the digital world, that our kids were falling apart, which would mean that they would even have, hard time in their homes with their parents.
Already we have ideas in the works to possibly create a library, possibly create educational material and educational media so that we can broadcast from our village, so that our message gets outside of the village and gets outside of Hawaii and connects to places all over the world.
We've been really trying to advance ourselves, trying to get ourselves out there so that we can be sustainable, so that we can be independent from everything else that stops us from moving forward. And this is just one more step in that direction.
Thank you. Great. I think people are ready for lunch. Thank you very much for listening.